Good morning, everyone. My name is Queen Etobona, and my student ID is 77406884. My project topic is on data mining for sports analytics, and the aim and the objective is to analyze the different data mining algorithms and techniques in rugby to improve player performance, predictions, game strategy, and injury prevention within the coaching and management system. The, this project have three major objectives. The first one is to compare the accuracy and the applicability of different machine learning algorithms in predicting player and team performance. The second is to identify and analyze the key indicators and patterns related to player injuries using historical and real-time data. While the third one is to validate the models that provide actionable insights for game strategy. Various methodologies were used in this project, and the first one, which is called the data collection. I sourced out my data from Cargo, where after downloading the data and getting it approved, I went ahead to clean the data and preprocess it, ensuring that the data was suitable for the analysis. I removed redundancy and outliers. And then I went ahead to choose my various machine learning models, which include sklearn, logistic regression, SVM, random forest, decision tree, and MLP. So for the first objective, which is to compare the accuracy and applicability of different machine learning algorithms in predicting player and team performance, I started by defining the features and the target variables, where the target is whether a player or a team achieved high performance based on the points scored. I then went ahead to split the data into two, the testing data and the testing set and the training set. Next, I initialized various machine learning models, which have already initially been mentioned in this recording. But these models were then trained and evaluated using accuracy, precision, recall, and F1 score to determine their effectiveness in predicting player and team performance. The results helped me to compare the applicability of different algorithms for this task. The second objective, which is to identify and analyze the key indicators and patterns related to player injuries using historical and real-time data. In this objective, I focus on identifying and analyzing key indicators related to player injuries. I begin by examining the correlation matrix to see relationships between the different variables, such as the minutes played, the games played, and penalties. This helps me to understand how these factors might be associated with injuries. I also visualize the total penalties by the player position to identify patterns that could indicate higher injury risks in certain positions. This analysis provided insight into key indicators that may be related to player injuries, how to prevent player and to protect players, or give our players enough time for recovery. The third objective, which is to evaluate the models that provide actionable insights for the game. For this objective, I aim to validate the models that provide actionable insights for game strategy optimization. I first of all define the features and target specifically for game strategy optimization. After splitting my data into two target variables, which is the training set and the testing set, I then went ahead to use various machine learning models such as the logistic regression, the SVM, random forest, decision tree, accuracy, decision tree, and MLP to train the data. These models are then evaluated using the precision, accuracy, recall, and F1 score. The results from these models would help me determine the best strategies for optimizing game performance, providing actionable insights that can then be applied into real-time game scenarios. The outcome of this discussion revealed that consistent player engagement and highlighted the impact of playing time and disciplinary action on injury risks. Time series analysis also indicated a peak in playing time around 2016 to 2017, followed by a decline, possibly due to external factors that reduced the match schedules, such as COVID. Among the machine learning models, the decision tree model achieved the highest accuracy and F1 score, demonstrating its strong predictive power. And also, the random forest model showed exceptional performance in predicting a high player performance with accuracy and precision exceeding 99%. So, to conclude this presentation, we would take a look at the future directions. The first future directions that could really impact a better outcome for my research is incorporating additional data. Future research could benefit from incorporating a more diverse data set, including detailed injuries reports, player fitness data, and psychological factors to further refine the predictive models and provide a more holistic understanding of player performance and injury risks. The second one is to explore a more advanced machine learning techniques. The use of more sophisticated machine learning techniques such as deep learning or ensemble models could enhance the accuracy of our outcomes. They could enhance the applicability of performance prediction, particularly in capturing complex and non-linear relationships within the data. And lastly, the longitudinal studies. Conducting a longitudinal studies that track player performance and injury data over an extended period of time would provide a deeper insight into the long-term effects of playing time, position-specific risks, and other factors such as player health and player longevity. Thank you. For